Okay. And this is not gonna take us the entire class period, so you guys should be able to get out early today. Okay, so according to the videos, we're gonna keep referring back to these two questions. So have those two questions handy because I'm gonna keep coming back to them over and over and over and over and over again. By the way, I didn't do this, I didn't compliment you. Everyone did really well on the last test, so way to go. I'm proud of you. Remember how I told you that if you would put in some effort, this could be your grade boosting grade. All right, and you guys all came through on that, so I'm proud of you guys for that. All right, so we're gonna graph here without a calculator. If you pretended that this had an equal sign instead of a greater than or equal to, what kind of figure would it be? It would be a line. And how do we know it's a line? Because there's no, it's not the equal to that tells me that, because think about the parent y equals x squared. That's having equal to, but it's not a line. What does y equals x squared look like? Yeah, so it's not the equal to that tells me that. What tells me that this is a line? I'm sorry? Yeah, I have no exponents. I have nothing weird. I don't have any square roots. I don't have any exponents. I don't have any absolute values. Think back to your parents, okay? And all of those symbols that cause weird things to happen with your parents are not existent here. So I know it's a line because I have just a normal old x and a normal old y with nothing else going on. Now, there are two ways that you can graph lines. You're in Math 110, okay? This is not a lesson on how to graph lines, because that's a Math 101, Math 102, okay? So, but I will remind you of how to graph lines in case you have forgotten. All right, there's two ways to graph lines. You can graph with using either y equals mx plus b. Is there like a little ding, ding, ding? Oh, I remember something about that. Okay, so y equals mx plus b, which this one is not in that form right now. So let's talk about this. Y equals mx plus b. What did the b do? Yeah, it's the y-intercept. And what did the m do? Yeah, it was the slope. So what I would do is I would go graph my y-intercept first. Like let's say it was 4. I'd go to the y-intercept of 4 first. And then I would do what the slope told me to do. Remember, it's rise over run. The top number would tell me my up and down movement. The bottom number would tell me my right and left movement. Okay, so that's the y equals mx plus b form. The second form that I'm going to use here for example number 1 is the finding intercepts form. Okay, finding intercepts. Now we have found intercepts all the way back as far as chapter 3. Okay, so intercepts, this is not a big deal. All right, this is a good time to talk about it since you have an exam that's going to be comprehensive and cover everything, right? So what do all x-intercepts have in common? A 0 on the y value. And what do all y-intercepts have in common? No. A 0 for the x value. Well, that's exactly how we go find our x and y-intercepts. So for this guy, and by the way, for the time being, I'm just going to pretend it's an equal to. I'll deal with the inequality in a minute. So let's just come up with a little xy chart. Let's plug in 0 and figure 0 for x and figure out what y is. And then in a minute, we'll plug in 0 for y and figure out what x is. Okay, so we're just finding x and y intercepts here. So if you plug in a 0 for your x value, you plug in a 0 for your x value. So in other words, you want this guy to totally go away, right? Solve the rest of the equation. Again, pretend it's an equal to in there right now. What do you get for your y value? Y equals -2. Okay. And then you want to do the same thing. You want to plug in a 0 for your y value. So you want this whole term to go away because it's going to become 0. And solve, and your x value is +2. Well, now what I've done is I have created 2 coordinates. And I can connect 2 coordinates. We already know it's a line, all right? and I can connect my two coordinates with a line. All right, so let's go ahead, and I'm gonna, since these are little numbers, I'm gonna spread things out a bit. So I'm gonna say that this is 1, 2, -1, -2, etc. So 0, -2 is down on the y-axis, and 2, 0 is on the x-axis. Now, I know I'm going to connect the dots with a line. We've already discussed that. But now let's go to the two questions from the video. Okay, so what's question number 1 in the video? All right, so we have to figure out, am I supposed to be graphing my graph with a solid line or with a dashed line? All right, now, can you answer that question? Solid or dashed? Why? Because I have an equal to. Because I have an equal to. All right, so I'm gonna graph my line with a solid line. Look something like this. By the way, use a straight edge. You know, like everybody has a straight edge. Oh no, I didn't bring my ruler. But you've got probably a driver's license or a credit card in your wallet. They all have straight edges. Or your calculator case a lot of times has a straight edge. Or a piece of paper folded up 4 times, that's straight edge. I mean, everybody's got access to a straight edge, even if you didn't bring a ruler. Okay, so question number 1, solid or dash, we figured that out. What's question number 2? Yeah, where should I shade? Now, guys, the question does not say, should I shade? This is not a, every semester, I get a student who comes to my desk while I'm giving the exam, and they say, Ms. Roberts, am I supposed to shade on this question? And I look at them ever so sweetly, and I say, okay, because you gotta know, this is not, should I shade or should I not shade? I'm gonna shade. The question is, where should I shade? As long as you've got a greater than or less than symbol, you're gonna have some shading somewhere, okay? So where should I shade? Now, I gave you 2 different options. Okay? One of those options had to do, let's come up and look at them. No, yes I did, 2 options. Solve for y, and decide whether the shading is above or below. Now, the key to this one, guys, is the solve for y part. Y has to be alone before you can just automatically say it's going to be up above and it's going to be down below. Y must be alone. Okay, so the key here is that if you've got a y is greater than, then it's going to be above, and if you have a y that's less than, it's going to be below. Okay, that's option number 1, which we do not have. Okay, our y is not alone. So we need to look at option number 2 that says you're going to use a test point. Now, use something easy. Yes, I could use a test point that's ugly, like 9, 7. Or I can use something easy like 0, 0. Because what numbers are easier to plug in? 9s and 7s or 0s and 0s? Yeah, well, you know the answer to the question. Okay, so we're going to plug in 0, 0. Now, here's the thing. Sometimes what's the test point for? The test point's going to tell me what side of my figure I get to shade on. Well, if the test point is right on my figure, like if my test point 0, 0 is right on the line, I don't know if I'm supposed to shade on one side or the other side because it's on the line. You see what I'm saying? So that's why I gave you several different options. 0, 0 would always be my first choice. But if my line or my parabola or my whatever goes through 0, 0, I can't use that for a test point. Okay? So that's why I gave you a couple of different options there. So let's use 0, 0 for a test point, and let's talk about how do we run that. All right, so I'm going to put here test point 0, 0, and let's plug in our test point. Okay, so if we plug in our test point, 0 goes in for x minus 0 goes in for y, and then our equation, inequality, says greater than or equal to 2. and we do the math and we say 0 is greater than or equal to 2. And the question I have for you, is that a true statement or is that a false statement? It's a false statement. 0 is not greater than 2. Okay, so here's what we've got then over on our picture. 0, 0 was my test point. And you notice that 0, 0 is definitely on one side of the line, right? Oh, but 0, 0 told a lie. So the consequence is 0, 0 doesn't get to go to the shading party. The shading party is on the other side of the line. Okay, so here's where my shaded part is. So if 0, 0, or whatever your test point is, if your test point tells the truth, then your test point gets to go to the shading party. But if your test point tells a lie, the consequence is it cannot go to the shading party. It's on the other side of the figure. Okay, and I keep saying figure because we're not always going to graph lines. Okay, there's a lot of other things that we already know how to graph. Thinking back to our parents. Okay, so let's do, speaking of, this is a great time to review this because this is going to be on your exam. This is chapter 3 stuff right here. The only difference is the greater than symbol. Okay, so then for the time being, let's pretend it's an equal to. So what kind of figure is it? It's a parabola. Can you describe to me what's happening to the parents of my parabola? Talk to me about what's happening. Left, how far? 3. Why left? Good. And why left instead of right? Yeah, so remember the one on the inside acts backwards, right? Okay, so then left 3, and what else did you say, Abigail? Down 1. Okay, there's more, so not Abigail, what else? Okay, a vertical stretch by 2. Okay, so then let's go put all of this on our graph. Left 3, down 1. So let's do that first. Left 3, down 1. So here's my new vertex. Can I see how much you guys remember from chapter 3? Okay. Do you remember from chapter 3, we always started at the vertex and we always went, our parents went right 1, left 1, finish that statement, up 1, and then right 2, left 2, up 4, because 2 squared is 4. Remember that? Okay, so x squared, my 2 squared is 4. Okay, so that's what the parent does, right 1, left 1, up 1, right 2, left 2, up 4. Oh, but this is a kid, this isn't the parents. And because I'm stretching vertically by 2, I want to do everything double what the parent does. So I'm still going to go right 1, left 1. I'm still going to go right 2, left 2. This is not a horizontal change. This is only a vertical change. Okay, so I'm going to go right 1, left 1, up 2, up double what the parent did. Okay, so let's go put that on the graph. So go right 1 and left 1, up 2. And then I'm also going to go right 2 and left 2, up 8, because the normal parent is up 4. We want to go double that. So go back to the vertex, right 2, up 8, 2, 4, 6, 8, and left 2, up 8. Okay, so our parabola is mapped out. And now I'm ready for my 2 questions. So what's question number 1? Dashed or solid. And what am I going to choose? Because there's no equal sign, we're going to choose dashed. Okay, what is question number 2? Where is the shaded region? Now remember, I have 2 options for shading, right? One of the options is for when y is alone, and one of the option is if y is not alone, use a test point. So which of the 2 options do you want to use? Do you want to use the y is alone option, or do you want to use the test point option? Y is alone. Now, I will say this, the test point always works, no matter what, but the y is alone is a little easier, okay? So, y is alone, and so it says here in my inequality, y is greater than. So then if y is greater than, where is my shading gonna go? Above. Now, this is a little tricky. Where's the above? Yeah, it's gonna be inside the parabola, because if I go outside the parabola, it's gonna go down below it, right? So my shaded region then is everything on the inside of the parabola. All right. So then let's ramp it up a notch. Can you go back with me in your mind? All of chapter 7 was basically about solving systems of equations. Remember? So like in 7.1, we had three methods of doing that you already learned before. And then later on, we learned the RREF method that we used on the calculator. And then even after that, we used Kramer's rule. So we learned 5 different methods of doing the same thing, right? Ultimately, what was the goal of solving a system of equations? What do you say again? Get a coordinate point, and what did that coordinate represent? The intersection of my graphs, right? Where do these graphs cross over each other? Okay. Well, now that I have a system of inequalities, not a system of equations, but a system of inequalities, now I'm not looking for where do the graphs cross. Now I'm looking for where do the shadings cross. Where do the shadings cross? Because I'm not just going to have one coordinate answer. I'm going to have an infinite number of overlaying shading answers. Okay, so a system of inequalities then, where do shadings cross? Cross does not have a T in it. Where do shadings cross? Okay, so what I'm going to do here, I had 2 examples, I believe. Yeah, 2 examples. One of these examples, I'm going to do everything in the same color in case all you bring with you to your exam is just a pencil or a pen, and all you've got is one color. And then the second one, I'm going to do in multiple colors so that if you want to use multiple colors, you're welcome to do that. Okay. All right, so this is the one that I'm going to do with all in the same color. Nope, I'm going to do this one in 2 colors. I'm going to do this in 2 colors. The next one I'll do in the same color. Okay, so 2 colors on this one. All right, now when I look at these, by the way, I can't use substitution or elimination or Kramer's rule or RREF because I'm not looking for the one coordinate that they meet at. I'm looking for where the shadings overlap. So those are out, all of those methods. But so what's the only method? Of those 5, I just listed 4 that we can't use. What's the one that I didn't list? Nope, can't use that one. I cannot use Kramer's rule, RREF, substitution, elimination. Here's a hint. Graphing, that's the only method I can use. It's the only method I can use. All right, so, which is why I don't spend a ton of time graphing in section 7.1. I know I'm gonna get to it in section 7.7, okay? So, So let's graph these one at a time. What are they going to be when I graph them? They're both going to be lines. Again, there's no powers, there's no roots, there's nothing funky. I personally, when they're in this form, I personally like to use the intercept method. Okay, if it already looks like y equals mx plus b, I'll use this method. But if it doesn't look like this, I'm going to use intercepts. That's a lot easier, in my opinion. Okay, so for this first one, then let's use x and y, plug in a 0 for x, plug in a 0 for y. Let's solve and get two new coordinates. Okay, when you plug in a 0 for x, this guy goes away. What's left? Y equals 4. And again, for right now, we're just pretending it's an equal sign. We're not worried about the less than symbol. And then if I plug in a 0 for y and solve, x is 4. So we can go ahead over to our graph. And let's put that on the graph. So we have 0, 4, and 4, 0. Now I'm about ready to draw my line, but I need to go back to my two questions before I can draw my line. So what's question number 1 again? Solid or dashed? What is it? It's going to be solid. And what's question number 2? Yeah, where is the shading going to be? Should I go above or below? Now, my y is not alone. So what would you use for shading? Okay. What test point would you like to use? Totally. So when we plug that in, it's going to be 0 plus 0 is less than or equal to 4. Is that a true statement or is that a false statement? It's a true statement. So that means 0, 0 gets to go to the party. Okay. Now, I'm not actually going to shade yet. Let me show you what I'm going to do. Okay. I'm just going to draw a few little hairs on this side of my line to remind me which side. Because remember, my ultimate goal is to see where my shadings overlap each other. Okay, so I'm just going to draw a few hairs. It just reminds me before I forget, because I am forgetful, what side of the line my shading is going to be on. Okay, so first inequality then is completely finished. Let's move to the second inequality, and I'm going to change colors on the second inequality. Okay, we'll stick with the Christmas theme since today is December 1st. Okay, all right, so on the second line then, we'll do our XY chart again. So plug in a 0 for your X and do some solving. Again, pretend it's an equal sign. What do you have? Y equals -3. Plug in your 0 for Y, which makes this whole entire term go away, and X is 6. Okay. So let's go put that on our graph then. We have 0, -3 down on the y-axis and 6, 0 on the x-axis. All right, I'm ready for my two questions. Question number 1, is it solid or dashed? It's dashed. Let me see here. Okay. And now for the shaded part. How are we going to figure out where the shading is? Let's run a test point. What test point would you like to run? Again, let's run 0, 0. So when we plug in the test point, we'll get a 0 in for x minus a 2 times 0 for y is greater than 6. True statement or false statement? It's a false statement. So then where is the shading going to go? Now you have to ignore the red line, only pay attention to the green. Where's the shading going to go for the green line? Underneath it, yeah. 0, 0 doesn't get to go to the party because 0, 0 lied. Okay. Okay, now remember, the goal here is not where do the two lines meet. The goal is where do the shadings overlap. Okay, so can you tell where the shadings are gonna overlap? Where do they overlap? Can you describe it to me? Yeah, that bottom part, right? Okay, so we'll do this. And it looks like a Christmas tree. So then the point is here that I can pick any coordinate down in this shaded region, any coordinate in the world that you want to use. And there's an infinite number of points down here. I can use any coordinate. If I take that coordinate and I plug it into both of my inequalities, I'm going to get a true statement. Okay, so that's why I can't list out the answers. There's too many of them. There's an infinite number. All right, so this next one then I'll do in one solid color. All right, so what does the first one look like? An upside down parabola. Where is my vertex? 0, 0. And from 0, 0, tell me where to go. How do I get my other coordinates? Okay, so right one, left one, down one. And down 4, very good. So right one, left one, down 1, right 2, left 2, down 4. Now, when I graph this guy, how should I graph him? Solid. And what option should I use for my shading? Y is alone. By the way, if you used a test point here, could you use the test point 0, 0? You couldn't. Why not? Yeah, like the party is at 0, 0's house. He's already there. Okay, he's not either coming or not coming. Okay, so I couldn't, if I wanted to use 0, 0, I couldn't. So I'd have to use one of the other ones. All right, but we won't use a test point. We'll use Y alone. So it says Y is less than. So am I going to be shading down below the parabola, up above the parabola, and describe to me what that means exactly? Yeah, inside the parabola. Okay, so then let's move to figure number 2. What kind of figure is this? A parabola again. So talk to me about how should I draw this parabola? Good, so I'm shifting down 6 units. So that because this is in the same color, it's gonna get a little lost, so just be careful here. So I'm shifting down 6 units. And from there, where should I go? Okay, so here's my right one, left one, up one, and of 4. So it's easy to get lost. Okay, so try not to get lost in there. If you want to wait on the shaded part, you can wait on the shaded part. Now, when I go and graph my parabola, how should I graph it? Yeah, it needs to be dashed. All right. And how do you want to do your shading? Y is alone. And so what are you going to decide for shading? Above and on the inside of that dashed parabola. Good. All right, so that's going to look like this. And you say, oh, I can't really tell what the answer is, right? So if you do everything in one color, I'm fine with that. But as a grader, I also need to know what you're thinking. And so what you're going to do is you're going to follow up with maybe just darker of the same color. So I'm still going to use the same color. I'm going to go back to a solid here. But where is the shading overlapping? Can you describe to me where the shading is overlapping? Yeah, isn't it in that middle region there? So then what I'm going to do is I'm going to make this guy still solid, but a little bit more pronounced. And the underneath guy still dashed, but a little more pronounced. And then I'm going to follow up with, hey, Miss Roberts, here's my shaded answer. And then I look at this as a grader, and I don't need you to tell me what your final answer is because it's absolutely obvious to me what your answer is. Okay, so, but if you would like to bring highlighters or other colored pens or anything, if that would help you, go for it. I'm totally okay with that. Okay. All right, guys, that is all of the content I have.